am Dr. Razia Shemi Sanatgar from University of Borås Swedish School of Textiles, and today I want to present you 3D printing on textile as a novel process for functional and smart textile. This content is developed in the framework of TESTEX project, which is co-financed by Erasmus Plus project. 3D printing on textile is a new environmental-friendly method that addresses the problems of shortage of non-renewable material and energy sources. The method is more flexible, resource-efficient, and also cost-efficient functionalization method in comparison with conventional methods like screen printing. The technology will improve the ecological footprint by minimization of textile waste combined with reduced consumption of energy, water, and chemicals. This educational materials aims to provide a comprehensive yet summarized resource about 3D printing on textile as a novel process for functional and smart textile to a wide variety of interested scholars and industries. The expected learning outcomes can be summarized as below: understanding of existing problems and challenges in production of functional and smart textile, introduction to 3D printing, overview of 3D printing of monomer and polymers, overview on potential benefits of 3D printing on textile, challenges and affecting parameters, some applications of this technology in functional and smart textile development. Functional and smart textiles are used for different purposes, such as healthcare, interior textiles, automobile, protective clothing, communication, and entertainment, and are represented by different products like medical shirt, carpet, corset, firefighter suit, and optical fiber display. These are the common applications, but there are also some applications like ergonomic clothing. But still, there are some problems and challenges in development of these products, which are mostly influenced by cost and economy. Big companies push a product to the market when the technology is able to support the large-scale production. As the existing technologies cannot respond to customized production, the products hardly come to the market. The challenges are like lack of standards, need of awareness and education, and the integration of the function onto textile. So, we need to introduce more flexible technologies to open up new opportunities and fulfill the requirements of a functional and smart textile, such as cost and flexibility. What is 3D printing? The world of 3D printing holds a wide range of technologies. At the highest level, there are three major categories for production of a 3D part, including forming, subtractive, or additive manufacturing. Here, you can see the additive manufacturing process, which starts with a 3D model and then steel file, G-code file, and then it is printed in 2D layers. The main difference between several additive manufacturing processes are in the used material and the way of layer deposition. There are different examples of these additive manufacturing techniques like FDM, SLA, and SLS. There are advantages and disadvantages for each of these techniques and methods, but fused deposition modeling is one of the most practical techniques, which is based on heating and extrusion. It uses thermoplastic materials in filament form, and it is clean, simple to use, and office friendly. There are some controllable parameters in FDM technology like extruder temperature, platform temperature, printing speed, and so on. It is believed that FDM 3D printing on textile can be one of the solutions to open up opportunities and fulfill the requirements of functional and smart textile. The workflow of the method begin with a CAD modeling, and then the design is given to 3D printer. And as you can see in the figure, you can have polymeric patterns on certain places of fabrics, for example, to integrate printed sensors and interconnections. There are some potential benefits for these techniques, but of course, still there are some challenges for these kind of products. And some factors can affect the property of these products like adhesion, tensile properties, bending and drape properties, washability, and abrasion. Some parameters like FDM process parameters can affect the adhesion properties of 3D printed materials onto textile. Some of these processes are like extruder temperature, platform temperature, and printing speed. For going to further step, we want to combine the nanomaterials with additive manufacturing to get benefit of both nanomaterial and then technique of additive manufacturing. Therefore, combining nanocomposite with FDM 3D printing onto textile can end up to development of functional and smart textiles. There are some applications of this method, like using in-pressure sensors, electroluminescence devices, and also electrode applications in surface electromyography. This educational material introduced a novel technology for development of functional and smart textile. The most challenging problem in a smart textile market is that the existing technologies cannot respond to the customer's needs. Therefore, the economy and production scale challenges still exist. 3D printing is applied as a flexible technology to enable customized production with less water, chemical, and energy for different possible applications, such as integrating sensors and interconnections directly on fabric where they are needed, water and solvent free, as well as pattern functionalization processes. To see the rest of the intellectual outputs of the project Destex, please visit our website destexproject.eu. Thank you for listening, and bye for now.